In this video, we're going to look at geometric sequences. So first of all, what does a geometric sequence look like? Well, we've got 2, 6, 18, 54. So in this case, to go to the next term, we multiply by 3. Now that pattern repeats. So if we multiply the previous term by 3, we get the result we're looking for. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. Now this times 3 is known as a common ratio, abbreviated as R. Okay, and all geometric sequences must have a common ratio. Another way to work it out is to do 6 divided by 2, which gives me 3. And I can do the same thing here. If I do 18 divided by 6, that would also give me 3. So the common ratio is the same. In this case, it's 3. Here's another example of a geometric sequence. How can we find the common ratio? Well, we can do that by taking the second term, 5, dividing it by root 5. But this is a familiar problem. This is a third on the denominator. We would have to rationalize the denominator. So we're going to multiply the top by root 5, multiply the denominator by root 5, and what we end up with is 5 root 5, all divided by root 5 times root 5 is 5. The two 5's cancel out, so we end up with root 5. So the common ratio is root 5. Now what would happen if I take the third term, 5 root 5, and divide it by the second term? Well, they cancel out. So I indeed get root 5. So it's a geometric sequence with the first term being root 5 and a common ratio, R, also being root 5. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we need to identify the type of sequence stating the first term and its common ratio. So we can do the second term divided by the first term. Don't forget we need to rationalize the denominator here. So times by root 2 times by root 2. So we get 2 root 2. Now root 2 times root 2 is 2. The 2's cancel out, and we end up with a common ratio of root 2. Then we take the third term, 2 root 2, and divide it by the second term, 2. We also get root 2. So we can say that R is root 2. Don't forget this is called the common ratio. And the first term is also root 2 in this case. And we call this a geometric sequence. A geometric sequence. A lot of the time in geometric sequences, we can get real world applications. So we're going to go through some examples like this. So this question says stocks of a company are initially issued at a price of £18. The value of the stock grows by 20% every year. Show that the value of the stock follows a geometric sequence. So what we do for a question like this is we know it is increased by 20%. Now we know how to increase a percentage. So we're going to do, we always start off with 100%. So we do 100% plus the increase amount, which is 20%. So that gives me 120%. Convert that to a decimal, which is 120 over 100. Which is the same thing as 1.20. Now this thing is known as a multiplier. Okay, so the general strategy is to always work out your multiplier first. Now we've got that. Then what we need to do is write it down in terms of an nth term. So we can say that the nth term is going to be the initial value, which is £18. So we do 18, the initial value, times by the multiplier, 1.20, but now we raise it to the power of n. And most geometric sequences at GCSE will have this form. So that will give me 18 times 1.20 raised to the power of 10, and to 2 decimal places, that will give me £111.45. Here's another question. You can give the question a try and then you can go through my work solution. Okay, welcome back. It says a liquid is kept in a container. At the start of the year, the container is filled with 200 litres of liquid. Due to evaporation, at the end of every year, the amount of liquid in the container is reduced by 12% of its volume at the start of the year. Calculate the amount of liquid in the container at the end of the first year. So what we're going to do is think about this. What does it mean to be reduced? If we're being reduced, we're losing volume. So we'll have to minus it from 100%. So our multiplier now will be 100% minus 12%, which is 88%. Now that will give me 0.88. Now this is our multiplier. Now that we've got our multiplier, we can say, right, we know initially we had 200 litres of liquid. So we're going to say that the nth term, is going to be 200 times by the multiplier, which is 0.88 raised to the power of n. Now we want to find the amount after 1 year, so we're going to say when n equals 1, we can do 200 times by 0.88 raised to the power of 1. We can do that on our calculator, and that will give me 176 litres. Then you want to find that the amount in the container after 7 years. So we can say when n equals 7, we just plug in 7, so we do 200 times by 0.88 raised to the power of 7, and that's going to give me approximately 81.7, again, litres. Here's the final question. You can pause the video, and when you're done, I will go through my final solution. Okay, welcome back. The question states a basketball is dropped from a height of 20 feet. After the ball hits the floor, it rebounds to 85% of its previous height. So now what we're going to do is find out how high the ball will rebound after its third bounce. So what we do now is we say, right, we know it goes to 85% of its previous height. So 85% is our multiplier. So we're going to say 85% is the same as 0.85, and I'm going to annotate that as multiplier. That's our multiplier here. And then the initial height, so we're going to write down the nth term. So the nth term of this is the initial height, which is 20, times by the multiplier, which is 0.85, and we raise that to the power of n. And we want to work out how high the ball will rebound after its third bounce. Well, that's going to be when n equals 3. So you can plug it in straight away. 20 times 0.85 raised to the power of 3. That's going to give me 12.285, 12.3 feet.